All right. So I'm just gonna kind of make up some stuff on this to get us through to the final exam, and then redo these for next year in a kind of more reasonable way. I'm going to use my trial version, and I guess I'll just record this, which is clearly valuable. Okay. So pretty much the way you're going to do anything stats related for on the TI-84, you've got stat and you've got list, and you use the both of those together. If you click on list, it allows you to choose one. So that's like if you wanted to do the one variable stats on list 2, it'll automatically do list 1. So you do this to go and say, no, list 2. You've got operations, which is to sort them, things like that. You're not really going to use that for this. And then you've got math. So here, if all you want to know is standard deviation, min, max, mean, median, these things, these are here. Most of the time, you're going to want to go to stat. Here you can edit or sort the lists. You can run calculations. One variable stats is kind of the big thing that you might want. You've got a linear regression here. You've got, oh, I guess I have to, exponential regression, logistic. And over here on test, hello, keeps going forever. You've got ZT, 2 sample Z, 2 sample T. You have the prop test, which we did not do in on-ramps. You've got confidence intervals. And then down here we have the chi-squared and the ANOVA. Oops, I went past it, but anyway, you saw it. The other thing that you might need is distributions. So you see this, oh my goodness, I've just made this go insane. Quit. Okay, so right there above variables, you have distribution. So if you go to distributions, you've got normal, PDF, PDF stands for probability distribution function. So that's if you had a single value that you were putting in on something that had sort of just a discrete type of distribution with a normal approximation. CDF is cumulative distribution function. So if I put normal CDF, and then the lower, it goes from lower bound to upper bound. So you're saying what's the area between blah and blah, okay? It automatically has this 0 and 1. If mu is 0 and the SD is 1, that's when everything's already been standardized. So that's when it's just, what's the probability that Z is between blah and blah? Or what's the probability that Z is less than 5? What's the probability Z is greater than 9? Not 9, that would be insane. So what's the probability Z is less than minus 0.4? What's the probability Z is greater than minus 0.4? That kind of thing. If you don't have it already in standard units, and so you're given, say, let's take, okay, so let's say we were asked what's the probability that Z is less than 0.8. Then the minus 1 E99 stays. That is basically in negative infinity. Of course, it's not really, but it's close. I don't remember what I said, but let's say that we wanted to know the probability Z is less than 0.8. Then we would just do this. And that's the probability that it's less than 0.8. If instead you were given, let's say it's an IQ test, for example, and you want to know what's the probability that somebody's IQ is greater than 110. So then your left endpoint is 110 because you're doing greater than. Upper is now infinity, positive infinity, not negative. And the mean of that is 100. Of course, you would have been given that, and the ST is 15. Okay, so this is what you do when it's not already Z, when it's just a value and you know the mean and the standard deviation. So you get that the probability someone's IQ is greater than 110 is 0.25. Okay, so that's how you use normal CDF. So that gives you the probability of it being between one thing and another. Going back in, we have inverse normal. So these you did not use. T is just if you're doing T instead of Z, which I guess you might use, but it acts exactly the same. Inverse normal goes backward. So that's if you wanted to know, say, what's the 75th percentile for IQ scores, then you go 0.75 is the area because it's the 75th percentile, and this is always going to be area to the left. So if you wanted to find a range in between, you'd have to know what was on either side and do it that way. But normally you just want to know a percentile. So the area would be 0.75 if we're doing IQs. Okay, so we knew already that about 25% was above 110. So if I say what's the 75th percentile, it ought to give me 110, and it did. So that is under, again, distribution. Okay? Now, if you want to use those tests, so you want to do these, or you want to do one variable stats, which is how you get the mean. Well, let me just do this. Okay, so we go back to edit, and we're going to edit a list. So we hit enter there, and let's say that it was, let's say it was one of something like how many computers are in your house. So I'm just going to, so I just made stuff up there. I don't know. Okay, so random. It'll catch up eventually. Okay, so I've got 19 things in here. I'm going to go over here because I don't want to have to redo that to show you something. Let's suppose that I started and I went, oh, I messed up, and I don't know where I messed up, how I got off track. You don't have to delete each and every one. Go up to where it says L2, hit clear, and it hasn't done anything, but when I go back down, it's gone. Okay, so you just go back in. Alright, so now I'm going to hit stat again, and I'm going to do calculations. One variable stats, list 1 is the one I want. I'm going to skip over frequency because frequency list would be, well, I'll show you in a minute. Okay, so I'm going to just calculate. It gives me the mean. It gives me the sample standard deviation, the population standard deviation in quartiles. Okay, so that's what one variable stats does. Now suppose instead it was one of those situations where I just have a bunch of ranges and I know, say, that there are, here, let me go here. I'm going to edit. In list 2, I'm going to say that I have these ranges, and let's say the first one's from 0 to 2, the second one's from 2 to 4, the next one's from 4 to 6, but we don't know what any of the values is, so we use the average. This is from way, way long ago. So let's say that there are 5 people in the first interval, 3 people in the next one, 7 people in the next one, 9 people in the next one, 6 people in the next one. And those intervals, the first one was 0 to 2, so I use 1. The next one was 2 to 4, so I use 3, and so on. Okay? So now I have these people represented by these ranges. So there were 5 people that I'm just guessing 1 for each of them because it's the average of their interval. So now I go back to stat and I go to calculate one variable stats and I say, okay, so it's in list 2 actually. So I choose 2. And then the frequency list is list 3. And now I have the mean, standard deviation, all that same stuff about that list. Okay? So that's one variable stats. Now, if I wanted to run a test, let's say that I wanted to do say I want to do a 2-sample t-test. And I'm going to use data. If I was using some other method to form the mean and standard deviation, or I knew the mean and standard deviation, then I hit stat. So we'll do that in a second. So we're going to say that it's list 1 and 2. And let's say, so we have that it's not equal, less than, or greater than. So the question is, what is your alternative hypothesis? I don't even remember what the means were, so I don't know. So I'm just going to use not equal to since I have nothing. We want it unpooled and calculate. Okay, so now I've got T. I've got P, which I can compare to alpha, which is obviously gigantic. I have my degrees of freedom. Both of the means. They were very close, in fact, even though I didn't mean them to be. Both of the SDs. Both of the N's. Okay, so that gives me everything for a 2-sample t-test. So let's suppose instead that I didn't have the list. I was given in the question, do a z-test this time, supposing we have the large sample or population SD for both. So I'm going to go to stats. Oops. Stats. And I'm going to give it the standard deviations. So the standard, so this is population. Note, because I'm using a z-test, I better have had the population standard deviation. And even if I say data, it asks me for this, because when I told it z, I was telling it I have the population standard deviation. If I didn't, and I used a t-test, then it calculates it based on the standard deviation of the sample. But it's not going to use the standard deviation of the sample for a z-test. So I'll make that one 3. And I'll make the first average. It's using, note, the information from the lists that I had most recently chosen. It's just that I had to input the standard deviations for sure. So let's say that this was 13 and there were 15 of them, and the other mean was 12 and there were 9. So I'm going to do that my alternative hypothesis is now greater than, well, less than. Okay, so now we have still actually a fairly large P. I guess I didn't get them far enough apart. Well, I certainly didn't because my standard deviations were so big, but so this is how you do it if you know the population standard deviation, which you virtually never do. But just in case that shows up on an exam, go into Z and input that information. Okay, what else, what else? Let's do one sample. So just straight t-test. And I'll give it the data. And so now it asks me, to what mean am I comparing it? And those means were like 5, right? So I'll say I'm comparing it to 4. And we'll do list 1, it's fine. And it was bigger than, so I'll do bigger than. Calculate. Okay, T is 2.5, P is 0.01. So this one I would actually reject the null. And okay, so that's all the tests except chi-squared and ANOVA. Chi-square and ANOVA, I need to, well, one of the chi-squares I need to get more comfortable with, and so I'll make those videos later. This should get you started on your preparation, and also, I don't remember for sure, but I think maybe that the first half of the exam is like the first half of the semester, the year, so this should get you through that for sure. Chi-square and ANOVA hopefully are on the second half, but anyway, so I'll stop this one here, and this gives you plenty to kind of practice, and then I'll get the other one done either today or tomorrow.